So today we're going to be talking about the associative property of multiplication. You guys have already learned about the associative property of addition at this point in the year. So today we're going to be talking about the associative property of multiplication and how it works. So our learning target is that you can identify examples of the associative property. And we're not going to talk about the success criteria yet because we're going to kind of go through some examples and figure it out from what we notice. So what are properties of numbers? We talk about different properties. We talk about the associative property and the commutative property and the identity property. So what are those things? And properties of numbers are things that hold true no matter what numbers you're using. And there are always rules that follow these properties. So it has to hold true for all of these specific things for it to be an example of this type of property. So we're going to first revisit a property we already know. And in third grade, you learned about the commutative property of multiplication. And in the commutative property, you have a number multiplied by another number. And that just means that this side and this side are still equivalent, even if you say, well, I did 5 groups of 6 or I did 6 groups of 5. In both sides of the equation are still 30. And so this is true. And that holds true for all numbers. No matter what two numbers you put in here, it doesn't matter which one comes first or second. The reverse of this is always still true. And so that's called the commutative property. So the associative property is a little bit different. The associative property of multiplication talks about how numbers are grouped together. So it says that no matter how your numbers are grouped together and are being multiplied together, the product remains the same. So the numbers stay in the same order as they were written. So in the commutative property, you can see that these two numbers are in a certain order, and on the other side of the equal sign, they're in a different order. Okay, in the associative property, that's not true. We write the numbers sequentially the same. So they're the same order as they're written, but they're solved in a different order. So, and you're going to learn about order of operations next year in 5th grade. But order of operations just means that there's a certain way that we solve problems. There are certain steps that we follow. And the very first one that we follow are things that are in parentheses. So whatever's in parentheses is what you solve first. And so if the parentheses move, then the product remains the same. And that's what the associative property says. So let's look at an example. These are some blocks here that show two different multiplication sentences. Okay, this one says 4 times 2. And you notice how it's in red here, because that's what's in parentheses and that's what's done first. And you can notice that's what's done in the picture first. It's 4 by 2. Each of these little things is a 4 by 2. So that was what was done first, was a 4 by 2. And then they said, okay, I need 3 of those. So they did a segment here, which was 4 by 2. And then they did it 3 times. So this would be a 4 by 2 by 3, but the very first thing they did was what was in parentheses here. It's not because it's first in sequential order. It's because it was in parentheses. So if we look over here at these blocks are grouped differently. They are first grouped in a 2 by 3 manner. So 2 by 3, and then we needed 4 of those. So 2 by 3, 2 by 3, 2 by 3, 2 by 3. So they're grouped differently. You can see that these are grouped differently than these. However, if I counted up all of the blocks over here, there would be 24. And if I counted up all of these blocks, there would still be 24. The product holds true in both of these situations. So what do we notice about the blocks? We notice here, too, that the order of the numbers are written sequentially. Do you see how this says 4, 2, 3? And over here, 4, 2, 3. So they are still sequentially in the same order, but they're solved in a different order. So you can see this was 4 by 2 first, and this was 2 by 3 first. And the only thing that changed about this was the parentheses. So the parentheses shifted in this. So we could say that 4 times 2, in parentheses, times 3, is equivalent to or the same as 4 times 2 times 3. And again, the only thing that shifted was the parentheses. Okay? So our success criteria when we're looking for examples of identifying the associative property of multiplication, we need to know that the same digits are written in the same order. So let's check. 4, 2, 3, 4, 2, 3. And that the signs are solely multiplication. Just like in the associative property of addition, all of the operational signs had to be addition. In the associative property of multiplication, all of the operations must be multiplication. And there is a shift in parentheses. So this is grouped differently than over here. So if these are the rules, these are the things that must hold true about a set of numbers. And if they hold true, if all of these things hold true, then the equation is true and we say it is an example of the associative property. Now, in our last video, we learned about equality in an equation, okay? This does show equality. This is a true statement. But not all true statements that have the same value over here that they have over here are examples of the associative property. You have to remember that these things have to be true for them to be examples of the associative property. So is this an example of the associative property? Let's look at it. I know that part of my success criteria is that the numbers are written in the same sequential order. So I'm going to check 5, 3, 4, 5, 3, 4. I know that all of the operations must be multiplication. Yes, and yes. And I know that there must be a shift in parentheses. So because I know that this is an example of the associative property. Now, I also know that if I were to solve this, and you don't have to solve these, guys, but it does show why it's true. So on this side, if I were to solve it, I would solve this first. And I would know that 3 times 4 is 12. And then I would do 12 times 5, which is 60. Over here, I would do 5 times 3 first, which is 15. And then do 15 times 4, which is still 60, which proves that the product stays the same regardless of what operation you do first. So we checked our success criteria. Yes, we were able to say that the digits are written in the same sequential order. The operations are solely multiplication, and there is a shift in parentheses. And again, we proved it because we said, okay, this was 12 times 5, which was 60. This was 15 times 4, which was 60. And we were able to check off all of our success criteria. So let's look at these. Choose all that show the associative property. So I'm going to go through these one by one, and I'm going to go through my success criteria as I go. Are the digits in the same sequential order? 4, 5, 2, 4, 5, 2. Are the operations all multiplication? And is there a shift in parentheses? I can say yes to all of those things. So this is an example of the associative property. Let's go to this one. I already noticed something about this. I immediately see that the numbers are in a different order on this side of the equal sign. So this is actually an example of the commutative property. So this is a true statement and it is a property. However, it is not the associative property of multiplication. Let's look down here. Same digits in the same order. 4, 6, 2, 4, 6, 5. Oh, 2 different numbers here. So no. So to the next one. 2, 9, 3, 2, 9, 3. All multiplication. Parentheses shift. So I was able to say that this was an example and this was an example. And these two were non-examples.